Hello there, it's Jay here from Jay's Vintage Junk, and today, as you can see, we're back on with the PYE BV20 restoration. And as you can see, I've actually completed replacing all the wax paper capacitors. You look here, and I've stuck them in this bag because they are horrible. They're ridiculous, sticky, horrible things. But basically this has took me best part of a week. This section here was a nightmare. There was about 30 capacitors. Well, you can see them all, these little, you can spot these little green things here. These are all the replacement capacitors. There is a lot of them, as well as the section down there that we'd already recapped. And I'm just going to show you basically the reason why we've done this at this point. I've dug out my high tension bench power supply. This is an instrument from the 1960s. It's XMOD. But basically what this does is it provides you with a 6.3 volt low tension output there, and then a high tension HT up to 600 volts at 100 milliamps. What I use this for more than anything else is if I'm, say, experimenting with a valve circuit. I can actually power the valve circuit up, say I'm designing a preamplifier or something like that. I can prototype it on the bench and just use this as the power supply to actually power the circuit up. And it's nice, like I said, because it's a variable voltage power supply. It's much like a modern bench power supply, only it goes up to 600 volts. You know, it's a high voltage version, but it's also quite useful for testing capacitors. And I'll show you why we need to change these before we even attempt to switch this television on and power it up for the first time, because basically these are all incredibly leaky. What I've got the HT power supply here connected up with this meter. I'll switch that on. I've got that set to about 200 volts. It's on the 200 volts range. I will switch the make sure that that's off. Now I will say you have to be careful with equipment like this. You know, it does have the potential to do you some serious damage. You should only be messing with this type of stuff if you actually know what you're doing. But basically, what we can do. Let's get the leads from this. Now, which one is it? That one. So what we can do, we connect these two together and we start increasing the HT voltage. You'll see it appear up on that meter there, so we'll bring it up. You see we've got 15, 20, 30, 40, 50, about 100 volts there. Hopefully you can see that on the meter there. So that's, and if you look on the scale on the actual tester there, you can see there's 200 volt scale. We're about halfway down, so yeah, we're giving out about 100 volts. We'll turn that off. Now, as you know, a capacitor should allow AC to pass, but block DC. Now this is outputting high tension DC. So if we connect this capacitor in series, when we turn the meter up there, when we turn the voltage up, we shouldn't see anything up on that meter there, if this is a good capacitor. So we turn it up. Can see we've already got 13 volts showing on that capacitor. Let's take it a bit further. So we already know that capacitor is shot, it's completely leaky. I mean, I've got what, just under 50 volts, 60 volts on there, and we've got 25 volts of leakage through the capacitor. So I mean, it shows straight away that capacitor is no good. Just to show, I've got a brand new, let's just disconnect that one. Get that out of the way. I've got a brand new capacitor here. I think it's a 0.02 UF. If I connect across that one, and do the same thing, bring the now you will see it flick slightly as I increase the voltage, but I've got 100 volts on that capacitor there, and as you can see, we've got no DC coming through it at all. I mean, that capacitor's rated at 600 and I think it's 630 volts. So I mean, if we go right up to 200 volts there, like I said, you will see the meter just go up as I actually increase the voltage, but then you'll see it'll settle down, and we've got 0 volts going through. So you know that is a good capacitor. We'll turn that back down. Now just be aware that you could potentially have a charged capacitor there, so we've got to be careful when we remove that, because that could have about 200 volts still on it. The capacitor will store its charge. So we'll just very carefully disconnect it. We'll just short it out, just to make sure that capacitor hasn't retained any charge. Just be on the safe side. Put that out of the way. I'll just show you with another one from the bag. Fortunately, most of these I have cut the leads off, replacing them, but we should be enough to make a connection. So again, we've got another capacitor out of the bag that we've replaced. Just see if we can get a good connection on it. I think there's enough wire sticking out there to make a connection. There we go. Get that in the circuit, and then we can wind this up, and we'll see if there's anything there. You see straight away got 34 volts coming through that, so that capacitor is severely leaky. We'll turn that back down. Disconnect them from there again. So like, as you can see, that's the reason why I've taken all these wax paper capacitors out at this point, rather than see if I can get the set working initially and then change them as and when. All these are pretty much completely shot. These capacitors that I've left in here, these Sprague ones, however, these have a bit of a better reputation than those old wax papers, and we'll actually test those in the set. In fact, we can do one now, so I'll show you how I do. Basically, what we have to do is we have to disconnect one side of the capacitor from the set to do this. Now, this one, fortunately, this one should be fairly easy to do, because what we can do, that leg of the capacitor there, actually all it does is go through to one pin on a valve there. There's nothing else actually. I don't think there's anything else. Oh no, there is. There's a capacitor. No, that goes past it. There is just one pin on that valve connected to that the side of that capacitor. So what we can do is we can just pull the valve out. So we can just get to it and pull the valve out. There we go. So now that capacitor basically is isolated. So what we can do, if we put put the HT on the bottom of that capacitor, that's now isolated from the rest of the circuit, because I mean we probably wouldn't have had to take that valve out, but unless I actually look up the valve characteristics and the pin out for the EF50, I don't know whether that pin might not be internally connected to another pin that goes somewhere else on the circuit. And really you do need to isolate the capacitor to do this. So we've isolated one side of the capacitor. What I'd normally do, to be fair, is just cut one side of the capacitor free, and then when I've finished, if the capacitor is indeed okay, I can just put one of my little coils of wire between the two and solder it back in place, and it makes a fairly neat, virtually invisible rejoin. But like I say, in this instance, because we've been able to isolate that side, we don't have to do that. We'll connect the meter up to the other side of the capacitor, so it's exactly like we did over there. We've just left it in circuit, but like I said, because we pulled the valve out, we've made sure that that side of the capacitor is disconnected from the rest of the circuit, so we can apply the high voltage to it now and see whether we get any leakage through that capacitor. So let's bring this up. As we can see, yeah. So I've got about 50 volts on that capacitor, and as you can see on the meter there, we've got 20 volts of leakage on it. So even though that's one of them Sprague, one of those Sprague capacitors, which generally speaking, from experience, have tended to be okay, that one unfortunately is most definitely leaky. So that one there will have to be replaced. We'll try one more while we're in here. We'll do this one actually, because that one will be a nice easy one again. So that one's going to have to come out and put a replacement in. What I'll do is I'll snip the top wire off it there, because that's easy enough to, like I say, I can put one of my little coils on just to reconnect them once we've tested the capacitor. We'll connect high tension up to the bottom of the capacitor here. We'll connect the meter up to the, just make sure I've got that wire I cut out of the way. There we go. We'll connect onto the capacitor like that. And again, just make sure we've got a good connection on the bottom there. Yes, we have. There's some sleeving around the capacitor, but we should still be able to get a good, there we go. I think we've got a good grip on the wire there. Yeah, we've got a good grip on the wire there. So if we make sure we're not going to short on anything there, that's going to be okay. You don't want to have anything shorting together, which is going to give you a false reading. Like that. That wire there is just actually resting on top of the terminal, so let's just lift that and make sure that's well out of the way. There we go. And now we can test it. So we'll wind up the voltage. Now this one looks like it may be okay. Well, I don't know. We've got 5 volts of leakage there, but we've got about 150 volts on the capacitor. The capacitor is rated, I think it's rated about 300 volts looking at the size of it. We'll take it up to say, now there is some leakage in that capacitor, as you can see. We've got 200 volts on the capacitor and we've got 7 volts of leakage on it. So that I'd describe as switch that off for now. I describe that one as marginal. Depending where that one is in the circuit would depend on whether I left it in there or not. Because I actually want to use this set. Actually, if it's got a good CRT, or at least if I can find a good CRT for it, even if it doesn't, I would actually like to put this set into use and use it every now and again. So being that that capacitor is marginal, I'm going to change it. I'll change it out anyway. So I've basically only got like 1, 2. I've probably got another 4 or 5 capacitors to go through and actually either test or change completely. And then I think we might be at the point where we can actually give this thing a first test and actually see if we can get something on the screen. So basically, in the next video, I think we're going to be at that point. I'll test the rest of these capacitors, and I'll change out the ones I need to change out. And then in the next video, hopefully it won't be too long, because I really need to get this project off the bench, because I've got something else that I promised someone that I would get done. I want to get it done and back to them before Christmas, really. So that gives me a bit more of an incentive to get this thing actually up and finished. So join me in the next instalment of this, and fingers crossed we may actually see if we can get some light on the screen. So thanks for watching this little update, and goodbye.